Hello everyone, welcome back to series of data structures and algorithms. This is the second video where we will be exploring about array circular queue. By the end of this video, we will be exploring about what is array circular queue, uses of it and where it can be applied, and also we will implement it using Java. 皆さんこんにちは。データ構造とアルゴリズムシリーズへようこそ。今回のビデオでは配列循環キューについて学びます。それでは始めましょう。So let's first understand what is a queue. A queue is a linear data structure which follows first in first out principle. This means simply the element added first will remove first, just like a real life queue at a ticket counter.
キューとは何かを理解しましょう。キューは先入れ先出しの原則に従う線形データ構図です。これは最初に追加された要素が最初に削除されることを意味し、まるでチケットカウンターのリストのようなものです。There are several types of queues: simple queue, circular queue, priority queue, and double-ended queue. Simple queue follows the first in first out principle where elements are added from rear and removed from front. Circular queue is where the last position connects to the first, which forms a circle. Priority queue where elements are dequeued based on their priority, not just their position. Double-ended queue, also known as dequeue, where elements can be added and removed from both ends. Queue にはいくつかの種類があります。単純キュー、循環キュー、優先導キュー、両端キュー。単純キューは要素を後方に追加し前方から削除します。循環キューは最後の位置が最初の位置に接続され円を形成します。優先導キューは要素はその位置ではなく優先導に基づいて削除されます。両端キューは要素を両端から追加または削除できます。In any queue, we perform operations such as enqueue, dequeue, peek, isFull, and isEmpty. Enqueue is adding an element to the queue from rear side of the queue. Dequeue is removing an element from the front of the queue. Peek is checking the front element of the queue without removing it. isFull is checking if the queue is full. isEmpty is where we check if the queue is empty. queue では次の作業を行います。enqueue, dequeue, peek, isFull, isEmpty. enqueue は要素を後方に追加します。dequeue は要素を前方から削除します。peek は要素を削除せずに前方を確認します。isFull はqueue が満杯か確認します。isEmpty はqueue が空か確認します。Now let's focus on the circular queue. Specifically, it's implementing using an array known as the array circular queue. それでは循環キュー、特に配列を使用して実装された配列循環キューに焦点を当てて説明していきます。An array circular queue is a type of data structure that uses an array to implement a circular queue. Unlike a standard queue where elements are added at the rear and removed from front, a circular queue treats the array as if it loops back around, forming a circle. This allows efficient use of space by reusing slots which left empty due to dequeue operations. 配列循環キューは配列を使用して実装される循環型のキューというデータ構造です。通常のキューでは要素を後方に追加し前方から削除しますが、循環キューでは配列が一周して丸のように見える仕組みになっています。これにより削除作成でからになったスコットを採用することでスペースを効率的に使用できます。Uses of array circular queue. Buffer management. which manages continuous data flow in I/O operations. Task scheduling allocates time spaces to process in OS. Traffic management handles cyclic data transmission in networking. Printer queue, which manages printer jobs efficiently. Event handling processes real-time events in a cyclic order. Simulation systems models cyclic operations in simulations. 配列循環キューの使用法。ファー管理、I/O 操作で連続データの流れを管理する。オーディオやビデオのストーリング用の循環バッファーの実装など、バッファリングでも役立ちます。
Let's start implementing array circular queue using Java. First, we have created an package named array circular queue, and inside that package, we create a public class named array circular queue. Inside this class, we have declared the size of the queue as 5, and also we define two variables as the pointers of the queue, front and rear, to keep track of the first and last elements in the queue. We store the elements of the queue inside the array named items. At the start, the queue is empty, so we have initialized front and rear to -1 inside the constructor. So when we are adding an element or when we are removing an element, we should have an idea whether the queue is full. So in order to check whether the queue is full, we are creating an method called isFull. isFull method, and we can take an example. If the front is equals to 0 and the rear is equals to 4, then 4 plus 1 modulus 5 equals to 0, which means the queue is full. Next, we need a method to check whether the queue is empty. So for that, we have created a method called isEmpty, and the queue is empty once the front is equals to -1. Like if we haven't had any element to the queue, means it's empty, so the front equals to -1. Also, if we have removed all of the elements inside the queue, it also makes front equals to -1, which makes queue to become empty. Now let's see how to add an element to the queue. So to add an element for the queue, we have created a method called enqueue. Here's how it works step by step. It checks whether the queue is empty by calling the method which we implemented earlier isFull, and if the queue is full, it simply prints a message saying that the queue is full. If the queue is completely empty, means where front equals to -1, we set the front to 0 because we are going to add the first element, and we are going to move rear to the next position, and then we are printing a message confirming the insertion as inserted plus the element we entered. Now let's remove an element from the queue using dequeue method. First, the dequeue method checks if the queue is empty by calling the isEmpty method which we created before, and if it is empty, it throws an exception. Next, it stores the element at front, so we can return it later. If front and rear are equal, it means that there's only one element left, so we reset both front and rear to -1, making the queue empty. Otherwise, we move front to the next position using front plus 1 modulus size, where this ensures the circular movement, and then we return the removed element. So for example, we've added 5 numbers for the queue, and then we are calling dequeue method twice, so it will remove the first 2 elements from the queue and the queue will now look. So the queue will now has about 3 elements. Next we move on for the display method. We use this method in order to print all of the elements in the queue, like to print the content of the queue using I+1 modular size to wrap around if needed. So simply this display method prints all the elements. Like we can use this display method to print elements inside the queue. Now let's test our queue in the main method. So here's the main method. We have called the Java class by creating an object named queue. First we check if the queue is empty, and then if it's not empty, we are trying to dequeue an element. So to check whether the queue is empty or not, we have used the isEmpty method we created. And then we are adding 5 elements to the queue. We are trying to add the 6th element, but it will print saying that the queue is full because we only have declared that there's only 5 slots. So we can't add the 6th element for the queue. And then we will display the queue. Then we will remove an element from the queue using dequeue method. Also it will be printed as the deleted, it will print the deleted element. Also we are going to display the whole queue after deletion. And finally we are going to add the element number 7. To see how the circular queue reuses the empty space. And finally, after we adding number 7, we will display the whole queue. So we will run this program and see whether the expected outcome. So this is the final output we get once we run the code. Inside our main, first and foremost, we check whether the queue is empty and try to dequeue an element. So since the queue is empty, it prints as the queue is empty and cannot dequeue. And then we inserted 5 elements and tried to insert 6th element, which exceed the initialized value, so it prints as queue is full. Then we are displaying the elements of the queue. Next we are printing the indexes of the array. Then we are deleting an element. So array circular queue follows first in first out principle. So the firstly added element will be deleted first. So it deletes number 1. And then it displays the remaining elements with their respective indexes. And then we again tried to insert number 7. It shows the elements, it displays the elements inside the queue and the indexes respectively. So from this, after inserting number 7, it is clear that the circular queue reuses the empty space. That's how a circular queue works in Java. So we learned how to check whether the queue is full or empty, add an element using enqueue method, remove an element using dequeue method, and print the queue using display. これで Array Circular Queue の解説は終わりです。ここまでご覧いただきありがとうございます。次のエピソードでお会いましょう。That's all about Array Circular Queue. We discuss its concept, applications, and the code implementation. So see you in next episode. Bye bye.